When you want to deploy a containerized application to Kubernetes, you're going to want to go with a declarative approach. You don't want to, for example, run a bunch of kubectl apply -f or kubectl create -f commands in a CI/CD pipeline. That's very imperative, and it's I don't want to, well, it is a bad practice in my opinion. It does work, don't get me wrong, but you do want something that's a little bit more declarative. So in today's world, the best practice when it comes to declarative configurations is GitOps. Whether you use Argo CD, whether you use Flux, whatever controller you want to use, that is the declarative approach. And here's the thing, when you deploy containerized applications, that's great. You set up your GitOps controller, everything's being deployed, but what resources are those applications kind of taking? CPU, memory, storage. Remember, Kubernetes isn't this magical box that has unlimited resources. It's servers underneath Kubernetes, you know? Kubernetes is running on infrastructure, whether it's in the cloud, whether it's on-prem, whatever the case may be. There is memory on that server. There is CPU. There is storage. Well, the storage in the cloud isn't particularly saved on the managed Kubernetes service cluster, but it is saved on some server. Point being, there are limits. So in Kubernetes, when you're deploying applications, you want to, number one, think about how are you deploying it? Are you using a declarative approach? And the second thing that you want to think about is, are you setting up proper resource limits, resource quotas, resource requests? And we're going to learn how to do all of that in Portainer today, because setting all of this up on your own and just a standard approach, getting a GitOps controller up and running, setting requests, limits, quotas, it is a heavy lift. It is not a basic thing. It's not a basic configuration that you just get up and running and boom, you're off to the races. However, in Portainer, it's incredibly fast compared to like, for example, if I'm setting up Argo CD versus if I'm implementing GitOps in Portainer, we're talking 1 month compared to 2 to 3 minutes. It's pretty insane. So we're going to learn how to do all of that in Portainer right now. So let's see how we can manage GitOps. We'll use Argo in this scenario with and without Portainer. So now, by the way, I'm going to be going through this in an imperative fashion. There is a declarative method to manage Argo via the controller. Argo CD has a Kubernetes controller. However, it is an alpha. With that being said, I have heard of production environments that are using it in production, but I do just want to specify that the controller is currently in alpha. Okay, so that's why I'm showing the imperative model. So first things first, you would install the Argo CLI because you have to manage it via the terminal in an imperative fashion. Next, you would deploy the actual server. So you could use something like kubectl to deploy it, and then that's going to create a bunch of services for you locally. Then you would use the kubectl get secret command because there's an initial admin password that's saved as a Kubernetes secret. Now, one thing that I do just want to specify here is the simple fact that it's saved as a Kubernetes secret. Kubernetes secrets are not all that secure because they are stored in plain text via etcd. So this is a security concern in itself here, which is why a lot of folks that are using Argo bootstrap with SSO, single sign-on. And I'm not even showing that here because that's just another step that you have to utilize. Next, you can port forward the service so you can access the service locally, or you can tie it to a load balancer, and then you can get the configuration, add clusters, etc. Now, you can also install via Helm. There's a Helm chart that you can utilize for all of this as well. And then once you do that, you can actually deploy an application. So you can use the Argo CD app create command and you can deploy it. Again, there is a controller that you can utilize for this to deploy the application and to bootstrap the application, but it is in alpha, so choose your own adventure. All right. But there are a lot of steps here. However, let's see how you would do this in Portainer. So if I go to applications, I can click on create from manifest and I can specify where I want it to go. So maybe in default, then I can specify, Nginx app, specify my repository, the deployment type. So I'm going to GitHub, or so I'm going to Kubernetes rather, not GitHub. I am utilizing GitHub, but we are deploying to Kubernetes, not to GitHub, because that would be silly. All right. And then we would have to specify a repository URL. So I'm going to go ahead and I'm going to specify one of my Kubernetes examples URL, and then I'm just going to specify the manifest path. So nginx.yaml, here it is right at the root directory. And that's how you would typically deploy an application in Portainer, right? But if you click on this automatic updates button, and then you specify the poll, so the fetch interval in which you want the controller, the GitOps controller, to look at the repo and see what code has changed, and that's it. And then you click deploy, and you're done. So clicking that button, literally again, all we had to do was just simply click a button and boom, GitOps is up and running. That's it. Comparing that to running all of this code or going the declarative model and risking doing the alpha build, there are a lot of pros to utilizing Portainer to do the same thing, especially if you're new to GitOps and you don't have the engineers that can manage all of this for you and all of the YAML if you go the declarative route. So utilizing Portainer for your GitOps solution is definitely a good way to go when you're getting started.